Radioactive waste. So what exactly is radioactive waste? It's defined as byproducts of nuclear power generation and other applications of nuclear fission and nuclear technology. Basically, radioactive wastes are wastes that contain radioactive material. Radioactive waste can be classified in two ways: high levels and low levels. High levels are produced as a byproduct of the reactions that occur inside nuclear reactors and take one of two forms: spent or used reactor fuel when it is accepted for disposal, or waste materials remaining after spent fuel is reprocessed. It takes hundreds of thousands of years to decay, and this is the only way to become harmless. It must be handled and stored with care in order to prevent leakage into the environment. Low levels of radioactive waste are typically objects that have been briefly exposed to radiation, such as contaminated protective shoe covers, clothing, rags, mops, etc. It's typically stored on site by licenses either until it has been decayed away and can be disposed of as ordinary trash, or until amounts are large enough for shipment to a low-level waste disposal site. High levels of radioactive waste can be disposed of in various ways, but the most common would be deep geological disposal on land. A basic requirement for this disposal would be having the ability to isolate the radioactive waste from the environment until the radiotoxicity of the waste has decayed to non-hazardous levels. Another way of disposing high levels of radioactive waste would be deep under the ocean floor, also known as subsea bed disposal. This picture here is an illustration of the disposal of high levels of radioactive waste through geological disposal. As you can see, radioactive waste is surrounded by an iron inner shell, vacuumed and filled with gas and enclosed with a copper shell, and this is buried hundreds and hundreds of meters into the ground. Low levels of radioactive waste are usually taken to facilities that must be constructed and operated to meet safety standards. These facilities are usually isolated from groundwater and surface water. There are 4 existing low-level waste disposal facilities in the United States, and 95% of all low waste fades to background levels within 100 years or less, which is substantially different than high-level waste. 2 ways of storage of nuclear waste would be spent fuel pools or dry cask storage. Spent fuel pools involve storing spent fuel assemblies under at least 20 feet of water. About 1/4 to 1/3 of the total fuel load from the pools is removed from the reactor every 12 to 18 months. In a dry cask storage, fuel that has already been cooled in the spent fuel pool for at least 1 year is stored in a cask, otherwise known as steel cylinders that are either welded or bolted closed, like the picture down here. These would be examples of casks, and this is an example of a spent fuel pool. Some disadvantages of waste storage would be leaking of radiation if not stored properly. It can emit radiation for tens to hundreds of years. And radioactive nuclear waste can result in eutrophication, which causes death of animal life from lack of oxygen from leaked chemicals into the environment. Permanent storage of high-level radioactive waste has both its pros and its cons. For example, some of the pros would be all the spent fuel produced to date by commercial nuclear power in the United States could fit in one football field and be about 3 feet deep, which is some pros of permanent storage of high-level radioactive waste would be all the spent fuel produced to date by commercial nuclear power in the United States could fit in one football field and be about 3 feet deep. More than 5,000 spent fuel elements have been shipped over the past 20 years in specially designed casks without any accidents causing harmful release of radiation. Some cons of the storage of high-level radioactive waste would be that there's not really 100% safe permanent containment found yet. Nuclear waste must be completely isolated for an extreme amount of time also. Significant technical uncertainties about the safety of using geological repositions for isolation of this waste remain unresolved at this time as well, which causes some controversy. And truck accidents occur at the rate of 1 per 2.5 million miles traveled, despite over the past 20 years the shipment being safe. And these are our sources that we used.